Hello, today we're continuing our work with Target 3, circles. This is circles lesson day 2. Our learning outcomes for today's lesson are to find the center and the radius of a circle from an equation, then graph. So we did something similar in our last lesson. However, the equations today are not going to be written in standard form. So we're going to talk about what that looks like and what we have to do in order to graph. The second thing we're going to focus on is to prove or disprove whether a point lies on a given circle. So just as a reminder from last time, or refresher, when we're graphing a circle, we first have to identify the center, which remember is H and K, and we have to also identify the radius, which is R. So usually that we do that when our equation is written in standard form. And as I mentioned before, the equations are not going to be written in standard form today. So we're going to be working on putting them into standard form in order to identify the center and to identify the radius. So if you notice our standard form, we see that we have 3 perfect squares. So we have a perfect square for our x's, and we have a perfect square for our y's, and then we have our radius also squared. So when we look at our first example, and we know we have to find the center and the radius in order to graph, we start thinking about how can I write this as a perfect square? How can I represent these x terms as a perfect square? And how can I represent these y terms as a perfect square? And then you think, oh my goodness, that's why we worked on that last week. We have to complete the square. So we're going to actually do that 2 times. We're going to do that for our x terms, and we're also going to do that for our y terms. So we have to do it 2 times for one equation. So it can be a little overwhelming at first, but we're going to take it one step at a time, and it will be just fine. So what I'm going to do is, just like we did before, is I'm going to take my equation, I'm going to give myself some placeholders. So I like to work on this all at once, and I'm going to write my x terms, so x squared minus 4x, and I'm going to leave a space there for my constant. And then I have my y terms, y squared plus 2y, and then I'm going to leave a space for my constant, and then I'll have my right-hand side equal to 20. And luckily, there was no extra constant that I had to get rid of. It was already on the right-hand side, so I can just work on finding the constant for my x terms, finding the constant for my y terms, and go from there. So I'm going to go ahead and do each part, and then we'll write our equation all together. So if you remember from our work from last week, when we're completing the square, we take our b value and we divide that by 2, and then we square it. And that tells us a couple different things. Remember, it tells us how to factor our trinomial, and it also tells what constant that we use to add. So the b in this case is -4. I divide that by 2, and then I square it. So -4 divided by 2 is -2. -2 squared is -2 times -2, which is a +4. So again, if you remember, we take this value, -2, and we use this when we factor. So we'll say use when factoring. And then for this value, this is going to be our constant, what we're going to add. Okay, so I'm going to go ahead and add my 4. So I'm going to put it in my placeholder spot, +4. And then remember, since I'm working with an equation, what I add to one side of my equation, I also have to add to the other. So +4 over here. All right, so my work for finding the constant for my x terms is done. So I'm going to leave that there. Now for my y terms, I have to do the same kind of thing, but with my y terms. So I find my b for y. So b would be +2. And remember, when I complete the square, I take b, I divide it by 2, and then I square it. So in this case, b is 2. So 2 divided by 2 squared. 2 divided by 2 equals 1. And then I square that, and I get 1. So just as a reminder, again, this is what I use when I factor, and this is what I'm going to add to my equation up top. And I'm going to go ahead and do that now. I'm going to add 1, and that completes the square for my y's. And then since it's an equation, what I add to one side, I also have to add to the right-hand side. So I add 1 there. All right, so just to recap, so far what I have done is I completed the square for my x terms, and then I completed the square for my y terms, and I added constants to the left-hand side, and then I added those same constants to the right-hand side. All right, so I'm one step closer to completing the square. So now what I have to do is write them in factored form, and then it's going to really start to look like an equation of a circle. So I'm first going to write the x terms in factored form. So this trinomial here, I'm going to write that in factored form, and then I'll write my y trinomial in factored form, and then I'll also bring down my terms up here. So before we do that, I'm going to go ahead and just recopy it because I feel like this is kind of far away. Then I can move my paper up. I'm writing it all together, 2y plus 1. And then I know that the right-hand side is 20 plus 4 plus 1 is 25. All right, so I can go like this. All right, so now, like I said before, I'm going to write my x trinomial as a perfect square. I'm going to write my y trinomial as a perfect square, and then I simplified that right-hand side. So if you remember, when we write this as a perfect square, that's the number I use. I use my -2 before I squared it, and that's how an easy way to factor it. So it'll be -2 or x minus 2 squared, and then I add y, since this is positive 1, y plus 1 squared, and then I can bring down my 25. All right, so I have written my equation, so now that it looks like a circle, so now I can identify h and k and my radius. So in order to do that, I'm going to go ahead and see if I can write down h and k. So I'll write down my standard form, r squared, and now I'm going to go ahead and write this so I can see h and k. So x minus 2, so 2 will be my h, and then y minus k, and k will be -1 because I notice it has to be a positive 1. So a negative times a negative will get me that positive 1. So k will equal -1. And then 25 will help me get my radius. My radius squared is 25, so I know that r will just be 5. So my center is hk, which is 2, -1. My radius is 5. So now I have enough information to graph. So I'll go ahead and start with my center, 2, -1, and then I'll count out my radius of 5. So that is 5. I'll go 5 to the right, 5 up, 5 to the left, and 5 down. And that is my circle for the equation x squared minus 4x plus y squared plus 2y equals 20. Our second example, you'll notice right away, we are doing the same thing. We have to identify center and radius, and then we have to graph our circle, but it looks different already. So please note that there are more examples in the next video. So if you'd like to see more examples like number 1, there will be more available in the next video. But we're going to go ahead and go over the second type of example now. So the first thing I notice is that now all of my x's and y's are in different places in my equation. So just like I had before, I want to make my equation look like this to start. Notice I have my x squared and my x together. I have my y squared and my y together, and all of my constants are on the right-hand side. So I want the equation to look like this, and that will make it a lot easier to go ahead and complete the square. So that's my first step. That's my first goal. So in order to do that, I have to move a few things around. And depending on how comfortable you are with your algebra, you can either do that in one step or you can do that in as many steps as you need to get to the right format for your equation. So since I'm kind of walking this through with you guys for the first time, I'm going to take more steps, but feel free again to combine them all in one if you are comfortable with that. All right, so let's first go ahead and get our x's on the left-hand side, and then I'll worry about getting my y's over there as well. So we're going to go ahead and subtract 2x from both sides. So we get x squared minus 2x plus 4y minus 4 equals negative y squared. Now I'm going to get my y squared over there, so I'll add y squared. So I have now x squared minus 2x, and then I'm going to put my y squared in there, and then 4y minus 4 equals 0. And now I'm getting closer. I have my x's together, my x terms, my y terms, my y squared and y, and then I have this constant. The last thing I have to add, or I guess get rid of, is the constant. Remember, when I'm completing the square, I want all constants to go to the right-hand side, so I can add my new constants to the left-hand side, or I guess to both sides. So we're going to go ahead and add 4 to move that constant to the other side. And now I should be ready to go to complete the square. So x squared minus 2x, and then I'm going to save my placeholder, plus y squared plus 4y, save my placeholder for my constant, equals 4. All right, so now you can see I have everything together that I need. I have my x squared and x together, I have my y squared and y together, and then I have all of the constants, in this case is just 4, on the other side of my equation. So now I can start figuring out the constants that I have to add in order to complete the square for my x terms and to complete the square for my y terms. So let's go ahead and start that now. So first we'll deal with x's. I have negative 2 for my b. Remember, it's b divided by 2 squared. So that will be negative 2 divided by 2 squared. Negative 2 divided by 2 will equal negative 1 squared will equal positive 1. So remember, negative 1 is what I will use when I factor. Positive 1 is what I'm going to add. So I'm going to add positive 1 right away, otherwise I forget about it, to both sides. And now I can go ahead and move on to my y squared. So here, I'm going to do the exact same thing, but now I am worrying about the y terms. So here I have 4 for my b, so I still take b divided by 2, then square it. So in this case, b is 4, positive 4, divided by 2, square it. 4 divided by 2 equals 2. And then 2 squared will equal 4. So remember, this term before, or I guess this value before we square it is what we use when we write it as a factor. And then our 4 is what we add to complete the square. I'm going to go ahead and add 4 to both sides. And now I'll rewrite my equation down here so we can write it as a perfect square trinomial. So bring down my x trinomial, so x squared minus 2x plus 1. Bring down my y trinomial, y squared plus 4y plus 4. And then I have my right-hand side, which is 4 plus 1, plus 4 is 9. And now I can factor my x trinomial, factor my y trinomial, and find my h and k. So I have x minus 1, remember I use that minus 1 when I factor it, squared, plus y plus 2 squared, and that equals 9. So this is my equation that I have rewritten to find h and k. So that is my next step. I can go ahead and identify h and k and my radius, and then I will be able to finally graph. All right, so remember my standard form of my equation is x minus h squared plus y minus k squared equals r squared. So I can see that h will equal 1, positive 1, and k will equal negative 2. Remember, negative times a negative will be a positive 2. And then r will equal positive 3. So I have my center, which is 1 comma negative 2, and then I have my radius, which is 3. And now I have enough information to draw the graph. All right, so I'll go back up here. My center is 1, negative 2, remember, and radius is 3. So I start at 1, negative 2, and then I'm going to go out 3 units for my radius, and then I go up 3 units, and then I go to the left 3 units and down 3 units. All right. Again, if you would like to see more examples, I do have more examples in our next video. Otherwise, we're going to go ahead and work on proving whether a point lies on a circle. So our next example says prove whether a point lies on a given circle. And here is my point, and the circle is centered at the origin. So that means that the center is 0, 0, which means h is 0 and k is 0. And then it also contains the point negative 4, 0. So my circle has that center of 0, 0, and it also has the point negative 4, 0. So if you remember, our definition of a circle is that it's the set of all points that is equally distant or the same distance from the center. So since I know that this point is 4 units from my center, I can conclude that my radius is 4 units. And you don't have to worry that that might be a negative 4 units, because that in this case, it really just means the direction. So we can conclude that r in this case is 4. So you kind of have to infer a little bit what this piece of information is telling you. So I have a little coordinate plane that kind of helps you visualize this, but your practice will not have this. Feel free if you need to just to sketch a quick coordinate plane if you like to have that visualization. Otherwise, you're welcome just to write down what your radius is. So when we are trying to prove whether or not this point is on the circle, we have to first be able to write the equation of our circle, and then we'll be able to determine, is that point on the circle? So I was already able to figure out what h and k are and my radius, so writing my equation won't be too tricky. I have to just substitute everything in to the standard form, and then I'll have the equation of my circle. So since h and k are both 0, my equation will look a lot more simplified than what you guys have seen so far. So x minus 0 is just going to be x, and then we square that, so it's x squared. Y minus 0 is just y, and then y squared is y squared. So, and then we had 4 squared is 16. So this is the equation of my circle. Now I have to just figure out, is this point on the circle? You might be thinking, well, why don't we just graph it and then we can see, which it would work. However, I know that the square root of 7 is an irrational number, so that's going to be kind of hard to graph and really to see what if it's on my circle, because it's not going to live on the actual crossing on my coordinate plane. So it's going to be very difficult to just use a picture to prove. So we have to use a little bit more than that, and that's where our algebra will come in. So since we know we're given a point, x, y, and we have an equation, x squared plus y squared equals 16, one way we can determine whether this point is on the line is to see if this is a solution to our equation. So remember, we can determine if it's a solution by plugging our x and y in and seeing if we get a true statement at the end of our work. So that's how we'll prove whether or not the point actually lies on the circle. So I'm going to substitute in x, or I guess 3 for x, and then I will also substitute in root 7 for y, and then we're going to see, does this actually give us 16? So then all we have to do is just evaluate and see what happens. So 3 squared is 9. And then remember, the square root of 7 squared, those cancel out. So the square root and the square will kind of go away, and we're left with just 7. And does that equal 16? Yes, 9 plus 7 equals 16. So we have proved that this point is actually on our circle. So we say yes, 3 comma root 7 is on the circle. All right, let's go ahead and look at one more example. So again, we have to prove or disprove whether this point lies on our circle. And in this case, our point is 2 comma root 6, and the circle again is centered at the origin, and it contains the point 0 comma 3. So remember, we can conclude that since it's at the origin, the center is going to be 0, 0, which means h is 0 and k is 0. So we're right here at the origin. And then I know that it also contains, this circle also includes the point 0, 3. And again, since it's on the circle, I know that the distance between 0, 3 and my center will tell me my radius. And in this case, the radius will be 3 units. So r will equal 3. So just like last time, we have to go ahead and write the equation of our circle first, and then we'll be able to substitute in to see if we get a true statement. So I'm going to go ahead and write down this standard form. So x minus h plus y minus k equals r squared. And again, I just have to simplify. So x squared plus y squared equals 9. And now I can use substitution to figure out, does this point lie on the circle? So I have the point 2 square root of 6. This is 2 is my x. Square root is what I will substitute in for y. And we'll see if we get a true statement or something that is not true. So we'll substitute in 2 squared plus root 6 for y. So the square root of, I'm sorry, that was my puppy dog. So the square root of 6 squared, does that equal 9 squared? So we have to just evaluate our left-hand side. 2 squared is 4. The square root of 6, remember that square root and the square cancel out. So we're left with just 6, and we're trying to figure out, does that equal 9? Unfortunately, we can see already, no, 10 does not equal 9. So no, this is not on the circle. So we say no, 2 root 6 is not on the circle. All right, so as I said before, we're going to have another video that has a few more examples. Please feel free to reach out if you have any questions. Otherwise, I will see you in the next one. Thank you.